GCF is one of the things we're going to work on here. We're going to factor out the GCF and also learn something called factor by grouping. We're not going to get to that part here in this video. But what does GCF stand for? Greatest common factor. Good. So we all know that part. Let's look at problem number 18, which asks for the greatest common factor of 10 and 15, and just understand what's going on. Factors are the things that are going to evenly divide a number or an expression. So the factors of 10 would be 1, 2, 5, and 10. Likewise, the factors of 15 would be 1, 3, 5, and 15. And now when we're looking for the greatest common factor, it's just what number that's common to both of these lists is the biggest. So in this case, the GCF is 5. Not a big surprise there. For those of you who are really fortunate and have a graphing calculator, just a little quick FYI. If you hit the math button, then go over to number, last option down, number 9. Type in the 10, comma 15, and bada boom, bada bing, there you go. Awesome. Greatest common factor. Cool. All right. But now what we're worried about is more of the GCF in terms of expressions. And by that, let's take a look at a to the 5th and a to the 3rd. And understand what the GCF is here. So this is my own example. It's not one that's in the book. A to the 5th is a multiplied by itself a total of 5 times. And likewise, a to the 3rd is multiplied by a multiplied by itself 3 times. But if I asked you what they had in common, what would you say? A cubed. So when you're talking about the GCF of these terms that have exponents, then it's the most that they both have. Problem 26 is a nice example of that. They want the GCF between c squared and c to the 7th. What do they both have? C squared. It's the most that they both have. Good. Let's extend that a little ways to problems like number 32. 33 m to the 5th, 22 m to the 6th, and 11 m to the 5th. As far as the GCF is concerned, there's really a couple parts here. There's the number part, what's common to all the numbers, and then there's the variable part, what's common to all the variables. So let's start with the number part. Is there anything that's in common to all 3 of these? 11, sure, 11 divides each of those. How about the variable part? Is there anything in common to all of these? And of course the answer is yes. What is it? M to the 5th. Now you don't have 6 m's in common to all of them because these two fall a little bit short, so that the most that they all have is m to the 5th. Typically speaking, when we're working with greatest common factors, you're looking to factor out that greatest common factor. An example of that would be problem number 42. 18x plus 24. First things first, what is the greatest common factor? What's in common to both of these? 6. Now 6 is your GCF, but if you just gave me the number 6 for a problem that says to factor out the GCF, you're going to be missing a few points when you get your paper back. If I factor it out, what I need to do is I need to divide each of those terms by that factor. 18 divided by 6 is 3. So it leaves me behind a 3x. 3x plus what? 4. How could you check that if you're like, yeah, it doesn't look right? How could you check it? Yeah, distribute the 6. 6 times 3 is 18. 18x plus 24. So it checks. Another one like that is problem number 48. 33h to the 4th minus 22. Okay, well, is there anything in common to both of these? 11. Rochelle, if I factor out an 11, what's left behind? Perfect. And again, you can check by distributing. We'll work on some more after today, but I want to finish up with a little bit on factoring out -1. Now, in each of these previous two, when we factored something out, you're really dividing both of those terms by that factor. It's not a step that I often show. When the math gets a little bit more challenging, I'll actually show it. I'm going to show it now just so that we can figure out a shortcut, and then we're not going to do it again in terms of showing that missing step. So problem 58 gives you -x minus 2y, and they ask you to factor out a -1. So I'm going to put a -1 here. Now the step that I haven't been showing you is that when I factor something out, I'm really dividing every term by that factor. Just like here. 18 divided by 6 gives me 3. 24 divided by 6 gives me 4. But let's simplify what's in here. What's -x divided by -1? X. -2y divided by -1? Positive 2y. So my goal in this was to find a shortcut to go from here to here. What shortcut would you recommend to a friend to go from here to here without doing that step? What's the easy thing to do? Change the signs. Good. So you're going to put that -1 out here and just change the signs. Okay. If we can get